Okay, I'm gonna do this one. It's a little bit harder, but this is the type of problems you'll see on the exam, so might as well give them to you. Okay, so we are comparing these two molecules. We are trying to figure out if they are, enantiomers, diastereomers, whatever. We're trying to figure out their relationship to each other, right? So we have all these options. Always do the RNS, unless you obviously can't, right? If it's like this, like you're not going to be able to do the RNS. But now, still try. But if it looks like this, then you're probably going to be able to do it. Okay, so let's start here. Okay, these are not chiral centers, just according to our chiral rules. And if you don't know those, then go back to my video on just the general chiral center assigning priority video. So our chiral centers are here and here and here and here. Okay, I'm just gonna erase those. I just want to label them for you. So we assign priority by weight, right? So off rip, fluorine is number 1. If our chiral center is here, oxygen is 2. Then we have these. We have a carbon here and a carbon here. This carbon is going to be 3 because when we get to these carbons, right, when we're trying to assign priority, this one has 3 hydrogens and this one has a bromine, a carbon, and a hydrogen, and that's just automatically weighs more. When you do these enough, you should be able to just look at it and assign priority very quickly. And 4. Okay, so we have there's a couple shortcuts. There's one shortcut that works for me, that works for almost anyone, pretty much everyone. It's a little easier than like reorienting the molecule and trying to visualize things. So just like normal, we ignore 4, right? And then we go 1 to 2 to 3, okay? And that would say S, right? Okay, now our original rules are if 4 is in the front, we flip whatever chiral center we find. If 4 is in the back, we keep it. But what if 4 is in the plane? Okay, if 4 is in the plane, then you find your regular chiral center. Then if 1 or 3 is in the back, you flip it. Okay? And so a normal scenario is we're always worrying about what position 4 is in. Right? Once we find our chiral center, then we go to 4. Okay, where's 4? If it's in the back, we keep it. If it's in the front, we got to flip it. Okay? But now we have another position. 4 can be in the plane. If 4 is in the plane, then we have another set of rules. If 4 is in the plane and 1 or 3 is in the back, you flip it. And this applies only to this situation. Okay? If you're going to use the rules, these little shortcuts, make sure you have them by your side when you're doing the problems and reference them for each scenario. And this scenario is if 4 is in the plane, just a straight line, right? Okay, so I'm going to erase these so I can have room. And this one we said was S, right? So we have an S over here. Then for this carbon, we're at this one. Bromine's 1. This one is 2, and this one is 3. And then hydrogen is 4, and that's going to be R. And 4 is in the front, so we flip it. So it's really going to be S. So this first one is SS. Okay, I did that quickly, but pause it and do it in your head, or pause it and do it on paper, so you can do it. But I'm just going to keep moving only because this is a recorded video. If this was like live in person, that I would take my time, but I wanted to do this one, so I don't want to take too long. Okay, so this one, right? First priority, fluorine. Second priority, oxygen. Third priority, this one. Fourth priority is over here, right? For the same reasons, right? Fluorine weighs more than oxygen, and then when we get to this when we get to 3 and 4, this carbon has a bromine, a carbon, and off rip that weighs more than all 3 hydrogens. Well, just the bromine alone weighs more than all 3 hydrogens, so that's going to be our priority. Okay, so 1 to 2 to 3, because we are ignoring 4. That's just our normal rule when we're doing priorities when we're trying to do RNS. So that's going to be S. Okay, now we have to consider where 4 is. 4 is in the plane, so we go into our brain, our brain area, right? And we remember that our rule is if 4 is in the plane and 1 or 3 is in the back, we have to flip it. 1 is in the back, so we flip from S to R. Now we go to this one. 1, 2, right? For the same reasons. It's going to be the same configuration as this one. It didn't change. 1, 2, 3, 1 to 2 to 3, R, but we flip it to S because 4 is in the front. So, okay. So this one went from S to R and stayed S. Okay. Now we got to figure out their relationship. These are diastereomers because when your diastereomers have at least 2 chiral centers. They also don't have to have a chiral center. There's a couple exemptions, but I'm not going to do that right now. But for the most part, 2 chiral centers. And then every center stays the same except one of them, right? As in this one. So let's go here, right? It went from SS to RS. There's an odd man out, and that's this R. So that's what I mean by every center stays the same. So let me give you more examples. What if we do R, R, SR, right? Another scenario. And this is SS, RS, right? And so if every center stays the same except one, then it's a diastereomer, okay? And so that's just a video on comparing 2 molecules that have some chiral centers. This is the type of work that it takes. It's not that bad, but again, there's just a step-by-step process. So hopefully this one was helpful. It's a little bit more difficult, but it's good to do problems like this because it's helpful to do the difficult ones as opposed to the easy ones because you learn more.